Today we're going to continue with the notes, and today we're going to talk about end behavior. End behavior of a graph describes what happens to the function values as x approaches positive and negative infinity. So you're talking about which way the arrows would go if you were going to graph it. And in order to find end behavior, you need to know if the leading coefficient is either positive or negative, and you have to know if the degree is even or odd. So now we're going to look at this chart to talk about end behavior. And it's important that you fill this chart in accurately because this is what we're going to use in order to find end behavior. So the first thing I've done, if you look, is I filled in 4 different graphs. So I filled in when the degree is even, 2, 4, 6, 8, and the leading coefficient is positive, that means your graph is going to look like this top box. And to describe the end behavior, we're going to write this as x approaches negative infinity. We're going to say f of x approaches infinity. And we're going to say as x approaches positive infinity, then f of x approaches positive infinity. So the reason why we're saying that is as x approaches negative infinity, that means we're on this left-hand side, and notice our arrow's going up here. So that's also at positive infinity. As x approaches positive infinity, on the right-hand side, notice this arrow always goes up. Okay, then we're going to look at the next one. We're going to say if our degree is odd, and our leading coefficient's also positive, our graph is going to look like this. So for this one, we're going to say as x approaches negative infinity, f of x also approaches negative infinity. That's how you'll write your answer. And then we're going to say as x approaches positive infinity, f of x is also going to approach positive infinity. Okay, and then we're going to have one down here at the bottom. For this one, it's going to be our degree is even, but our leading coefficient is negative. So for this one, we're going to say as x approaches negative infinity, then f of x approaches negative infinity. As x approaches positive infinity, f of x approaches negative infinity. And that's because both of our arrows are going down here. Then we're going to have one more. So for our last one, this is when your degree is odd and your leading coefficient is negative. So this one we're going to say as x approaches negative infinity, our f of x approaches positive infinity, and as x approaches positive infinity, our f of x is going to approach negative infinity. Okay, so example 1 says determine the end behavior. Well, before we determine our end behavior, we need to look at the degree, and we need to look at our leading coefficient. So our degree, remember, is your highest exponent. So we're looking at this term. So our degree is 3, and our leading coefficient is going to be that number out in front, which is going to be negative 5. So our degree is 3, which is odd. Our leading coefficient is negative. So odd and negative, that means we're looking at this example down here. So we're going to say for our answer then, as x approaches negative infinity, f of x approaches positive infinity. And as x approaches positive infinity, then f of x is going to approach negative infinity. So our next example says g of x equals 2x squared plus 8x plus x to the fourth plus 4. Notice this one's not in standard form. So let's put this in standard form first, which means that we're going to start with our highest exponent. So we're going to say x to the fourth, then our next highest, so plus 2x squared, then our plus 8x, and then at the end here we'll have plus 4. So that way now we're in order and we can say our degree is 4, that's our highest exponent, and our leading coefficient, that would be like having a 1 out in front. So now our degree is 4, which is even. Our leading coefficient is 1, which is positive, which means we're looking at this top right-hand box from our chart. So to write our answer, we're going to say as x approaches negative infinity, that means that f of x approaches infinity, which I'm just pulling straight off that chart. And as x approaches positive infinity, then f of x also approaches positive infinity. Okay, next example says f of x equals 4x to the 7th plus 3x cubed plus 5. So this one's already in standard form. So once again, we need our degree, which is our highest exponent, which looks like it's 7. And we need our leading coefficient, which is the number out in front of our highest degree, which is 4. So it looks like on this one, our degree is odd, and our leading coefficient is positive. So the top and to the right. So our end behavior, we're going to say as x approaches negative infinity, then f of x approaches negative infinity. And as x approaches positive infinity, f of x approaches positive infinity. And once again, all you're doing is looking for the appropriate box from the chart and then just filling that in. So last example, we have g of x equals negative 2x to the 6th plus 4x to the 4th minus 5x plus 1. So this is in standard form. So our degree, one more time, is the highest exponent, which is 6. And our leading coefficient is the number with that highest exponent, which is negative 2. So it looks like this time we have a degree of 6, which is even, and a leading coefficient of negative 2, so negative. So we're looking at this purple box down here. So we're going to say as x approaches negative infinity, f of x also approaches negative infinity. And as x approaches positive infinity, then f of x approaches negative infinity.